So now we are solving the given initial value problem. In this initial value problem, we have given this differential equation as y double prime is equal to x to the power 4, right? And then we have given two initial conditions. Y at 2 is given as -1 and y prime at 2 is -1. So to solve this initial value problem, we'll be first solving the differential equation. That means we'll be getting the general solution of this differential equation if possible, and then applying the initial condition, or we'll see what to do next. Okay, to find the differential equation, to solve the differential equation, here you can see we have y double prime is given as a function of x, right? So to solve this differential equation, what we do here is we can apply the repeated application of the integration. So let's try to do that. So we have given here y double prime is equal to some function of x, that means x to the power 4. So if we have that, or if we have given the second derivative as x to the power 4, the first derivative of this can be applied by just finding the entire derivative of x to the power 4 plus some integration constant. Okay, so that means y prime of x will be obtained by this. But we know what is the entire derivative of x to the power 4, right? So by the power rule, entire derivative of x to the power 4 would be x to the power 5 and multiply by the reciprocal of 5. So 1/5 times x to the power 5 plus c will be y prime of x. So this is the first application of the integration. We get this. So we can continue this process and get the general solution of this differential equation. Or what we can just do here is, since we already have given here the initial condition relates with the derivative, we can also apply that. So if you want to apply that, you can see here we have the derivative. We have given the derivative at 2 is -1. So I just want to evaluate the derivative at 2. Okay, so if I want to evaluate this, so this will be y prime at 2 will be 1/5 x to the power 5. We are evaluating the derivative at 2, so replace x by 2, so 2 to the power 5 plus c, right? So that's what we get. But what do we have given? Y prime at 2 is given as a -1, so we can substitute that over here at y prime of 2. So y prime of 2 is -1, that was given over here, so I'm substituting that, and this is equal to 2 to the power 5 is what? 2 times 2 times 2 times 2 times 2, so that means what? 32, right? So we have then 32/5 plus c. So if we do that, we can solve for c, right? From here, because c is the only unknown, so we get c equal to -1 minus 32/5. So if we isolate c, then that's what we get, which is actually, if you solve, what do you get? -5 minus 32/5. So we get -37/5 is the value of that integration constant. Now this will help us to get the particular derivative. So substituting the value of the c over here, we get y prime of x is equal to 1/5 x to the power 5 plus c. If you substitute this value that we have obtained, this will be minus 37/5. So this is what we get. But our goal is to solve the initial value problem, everything over here, and then what we just get is the derivative by just applying one of the particular derivative, by applying that particular the derivative initial condition. So to get the solution of this, what we just need to do is continue this process. Since we have the derivative, we continue to find the y of x, because now derivative is still everything is here is just the function of x, so we can still integrate. So that's what I was saying earlier, the repeated application of the entire derivative. So this function that we have over here as a derivative, we integrate that plus some integration constant again. So that will give me the general solution of the given differential equation, which already include the initial condition of the derivatives, but there was another initial condition relates with the function, which we'll apply soon. But before that, let's just solve this one. So what is the entire derivative of 1 over 5 x to the power 5? 1 over 5 is a constant, so write down as it is, multiply by x to the power 5. Its entire derivative would be x to the power 5 plus 1, so 6 multiply by the reciprocal of that. That's what we get, minus entire derivative of this constant will be that constant multiply by x, right? And then plus entire derivative of d, sorry, d is the integration constant, so leave that as it is. So we get y at x is equal to 1 over 30 x to the power 6 minus 37 over 5 x plus d. So that's the solution we get, but still we have not applied this initial condition over here. Y at 2 is given as -1, so which we will apply now. So if you apply, now evaluate this function at 2, so we get 1 over 30 2 to the power 6 minus 37 over 5 times 2 plus d. That's what we get. We have given y at 2 as -1. We can substitute that, so we get -1 is equal to, what is 2 to the power 6? 64, right? So then we get 64 over 30 minus 37 times 2 would be 74 over 5 plus d. Now we can isolate, solve for d. So if we isolate d and then solve for that, we get d equal to -1 minus 64 over 30, because we are subtracting that and adding 74 over 5 on the both sides. This is what we get then. And then if we solve everything over here, what do you get? We get, can you use your calculator and then see, we are getting what, 35 over 3 or something like that, okay? So that's our integration constant we get, right, for the. So then again, you will be substituting this value over here. So if you do that, then we'll be getting the solution as y at x is equal to 1 over 30 x to the power 6 minus 37 over 5 x. The value of the d we figure out after applying the initial condition is 35 over 3. So if that is the case, then this is what our required solution of the initial value problem.